Summary of this feedback amplifier. What is actually feedback amplifier means? What is the definition? Taking one portion of the output signal and feeding it back to the input. It's nothing but if you are connecting output to the input and in between you are doing some processing, that is known as actually feedback amplifier. Name itself say that feedback. So whatever you are getting, that you are feeding back to the original input portion. Okay, that is called as a feedback amplifier. Type of feedback amplifier we discussed. There is a mainly two type of feedback amplifier. One we have as a positive feedback amplifier, another one we have negative feedback amplifier. What is this positive feedback amplifier or negative feedback amplifier? In the positive feedback is a process when the output is added to the input and amplifier gain, and this process continues. That means if it is any amplifier is there, here the addition takes place to the feedback. We can call feedback output is VF and input is whatever we are giving VI. So addition of these two we known as a positive feedback. So what is negative feedback means? It is just opposite. It is a when output is subtracted from the input. So you are doing here subtraction. When input we are given, this is Vi or we can call Vs. Okay, we are what we discussed as Vs, and here we are giving as a Vf. So whatever Vi we are getting, this is okay. So the difference between positive and negative feedback, we can say that in the positive the addition of input and feedback. Negative feedback means addition of input, subtraction of input and output, addition of input and feedback output signal. So this is the two type of feedback amplifier. Now we will go with the what is or why feedback amplifier required. So why feedback amplifier means the major aim of the feedback amplifier required. One is we have to increase the bandwidth. So what is bandwidth? We discussed in the before that. So in the module 2 we discussed what is the bandwidth means. How many frequency the particular your amplifier is according to your formula. So if you take like this, so from this frequency to this frequency your gain formula will work. That means A is equal to V0 by Vi. Other portion it is decreases, it not work. So this feed portion particular is known as bandwidth. So this bandwidth is less if you use only amplifier, but if you using feedback, this width is more. That means more bandwidth, more frequency range you can work it on. That is the major advantage of the feedback amplifier. Second advantage is it is the noise anything is there that will actually take from the input and feedback, it will subtract and it will remove the error signal. So any noise is there that it will, so removing the noise also we will use the feedback, and because of removing all those noise the gain will be linearly varies. So we can call it as a linearity in the gain is in. So these are the major issues of a feedback why we are used. What are the disadvantage of feedback? If any process there is some demerit or disadvantage, so we can discuss about what is the disadvantage of this. So usually we can say major disadvantage, it will act as attenuator. So we can say that it reduce the gain, nothing but it reduce the whatever input output. So what happens usually, if you take like that, this is your amplifier, this is your beta, and here you are getting output. So the amplifier gain is actually very high, and this total gain you are calling as a AF. Okay, so AF gain is reduced because of this beta. So whatever gain you are given here, and major of this gain is reduced by your feedback. So your total gain, whatever feedback is, always less than your amplifier gain. So we can say that gain should be greater than your total gain, okay, with feedback. So this is the reason, because beta will reduce the gain. So the major disadvantage is it will reduce the gain, or attenuation action it will takes place. Second major issue is it is complex and over cost, like that we can say that. Okay, the design is bulky compared to the amplifier, so we can call that complexity. These are the two major issues we have to address in the feedback, and these are the main disadvantage of the feedback amplifier. Let's discuss the feedback property, something like gain desensitivity. Actually, the gain desensitivity can be measured as difference of total gain, that means A with feedback, AF, divided by total feedback. Okay, total feedback gain. So this ratio usually we known as a gain desensitivity. The gain is AF actually. So F means with feedback. So with feedback gain desensitivity we have to find. For that it is nothing but the ratio of differential gain to the total gain. Okay, so how can we find out these things? First we can find out what is AF. So we know that AF is nothing but, already we discussed, we are discussing on negative feedback. We can do positive feedback also, but usually everywhere we are using negative feedback only. So we will discuss all this stuff in negative feedback only. So in this negative feedback we discussed that AF is equal to A divided by 1 plus A beta. This is what we got for the total gain. This here we have DAF required. So make it differentiation of this. Before making that one, first we have to differentiate with respect to gain, because here we have the term gain is there. If you are not differentiating with gain, then all the term becomes 0, because the constant term becomes 0, we know that. So the first case we are doing that, differentiating respected with gain, that is we can call A. Okay, so what happens if you differentiation this one? So DAF divided by A, so is equal to, we know that differentiation of U by V rule, from that rule it is nothing but 1 divided by 1 plus A beta whole square. Okay, this is what we will get. If you simplify this one, that means you can shift this one to here. So you will get as differentiation of AF is equal to, we can call it as a differentiation of gain divided by, we will get as a 1 plus A beta whole square. Okay, this is what DAF you have. So this numerator portion over, now divided by AF you have to find for desensitivity. So you can find that DAF divided by AF. So what happens? Divided by AF if you do it, so you know the AF formula, apply this formula to here. So first DAF you will apply. So it is nothing but dA divided by 1 plus A beta whole square divided by, in this divided by we have to apply this formula AF. So AF formula you can apply like that, A divided by 1 plus A beta. Okay, simplify this one, so it will go up like that. So it is nothing but dA divided by differential A divided by 1 plus A beta whole square. Okay, and it's nothing but you have to get this one upper side, so you will get 1 plus A beta divided by A. Okay, this is you have divided by of this, so it will become 1 by A, 1 divided by 1 by A is nothing but A by A divided by 1. That formula we can apply. So in this we can make 1 plus A beta and square you can cancel out. So the final answer you can write as a differentiation of AF divided by AF is equal to 1 divided by 1 plus A beta. Okay, that is this portion, and differentiation of A divided by A. Okay, this is the formula representation for gain desensitivity. So remember that what is gain desensitivity means, nothing but the differential of gain divided by gain. Okay, that is nothing but we can call desensitivity. How to find? First find out differential of gain with respect to gain, and after that whatever changes you will get, that divided by AF do it. Okay, nothing new formula we have discussed already. Whatever discussed in negative feedback only we have taken, and we are summarized that equation, and we found this one as a final answer. This result actually shows the effect of variation in A, that means gain, amplifier gain, on total gain. Okay, migrated by the feedback amount. So 1 plus A beta is also called as a desensitivity amount. So this much amount it will change. So this is all about the gain desensitivity. Hi everyone. Next we will discuss about basic types of negative feedbacks. That means here we are talking about the types depend upon voltage and also current. How the voltage and current varies. So what are the different type of feedback amplifier possible here? So here mainly the basic type of feedback amplifier we are discussing about the negative feedback amplifier, how it works. So here the input and output you can take the two portions. So there is a two possibility of input, you can give it. So input can be given either voltage or you can given on current. Similar way output also can be taken from either in the form of voltage or current. So we know that it is something like 0 or 1, similar way in both. So if you have 0 or 1, how many possibility we have? We know that in the logic design it is a 4 possibility. Like that we can go with the all these possibility and how it works. So if you take as a first possibility, like we can take this one as an input, okay, and another side we can take out. So there is a first possibility we have. So input we can make 0, output 0, like that. Here we have input either VRI and output also VRI, okay. So we can take different combination. So input first we can take that first one voltage, okay. Similar way output also we can take voltage, okay. So now what we can call this one? This is nothing but voltage and voltage, okay. Nothing but voltage amplifier. Similar way we can take as a, in this voltage usually if you are connecting to the input or connecting to the output, it will varies. So for that here I will write one more the interesting stuff. We can write the voltage and current in technical form like series and shunt. Suppose the if you want to tell this is series or this is shunt, how it is? That we can make it from this table, something like that. If it is input portion we are discussing, then if it is series connection means it is voltage, okay. Similar way if it is input is current, then we are calling that one as a shunt or parallel. Similar way output it is vice versa. So instead of here it become current, so series means output it is opposite. Instead of voltage it current, but in current it become voltage in the shunt. So the major stuff we can call as a series and shunt. Remember that if input is voltage given, then the circuit is something like series connection. But if you given current, input is shunt. If you remember this much actually enough, that means what is the connection of input to the current and voltage, okay. So if you remember this one, the output is opposite. If it is voltage is series, in output voltage is shunt, okay. If current is shunt in input, output it is current is series. So it is vice versa operation. So we can give it something this name also. So what name it has happened for here? The input is voltage, so it become series here. Similar way here output is voltage, so it become as a something like the shunt. So this connection also, the voltage connection also sometimes calls as a series shunt feedback amplifier or voltage feedback amplifier, or sometimes it is called as a voltage and series feedback amplifier also, okay. That we will discuss later, don't worry about that. This is the one portion we have, okay. Similar way we can go for the second one. Input is instead of voltage, we can make it current. So here one more we have something like as a voltage only we can take it, okay. It's nothing but second combination. Current means we have this one is shunt, so it is also called as a current voltage feedback amplifier, or shunt voltage is if it is output, so it is shunt, so it is shunt feedback amplifier, okay. This is the another name what we have. Similar way we can write voltage current, or once again we will do same thing, okay. Voltage, so here voltage over, now we are going for current, okay. You can order it any configuration, it's okay. Voltage and current. Voltage we are usually calling as a series, and current we usually calling as a output is series one. So it is nothing but series feedback amplifier. Similar way one more stuff we have something like last one, current and current is not over. So current and current. So input also current, output also current. Usually what happens, input current is shunt and output current is nothing but it is a series. So this connection is also known as a shunt and series connection. So these are the main these are the major four basic type of the negative feedback amplifier, depending upon the input is either voltage or current, or output is either voltage or current. Now there is some interesting factor we have, that is on gain. So what is this interesting factor in gain? If both are input voltage, so gain we are calling as a voltage gain, because both output and input are voltage. Now here in the second portion, this is usually called voltage gain. Second portion we have voltage by current. So we know that gain is nothing but output by input. So output by input means here output is voltage divided by current. So V divided by I, we know that it is something like resistance. So it is called resistance gain or resistance amplifier, and this is known as voltage amplifier. Okay. So similar way here, voltage is input, current is output. So it is nothing but I by V. We know that I by V is nothing but conductance, and input output conductance we can call as a transconductance. Okay. Here also we can call as a transconductance, and this is nothing but transconductance gain. Okay. Similar way, the last one, both are current, so name it very easily. We have I0 by II, so it is nothing but current gain or current amp. Okay, so we can name it as a four type of another name of amplifier. First one is voltage amplifier, second one is trans resistance amplifier, third one is transconductance amplifier, fourth one is current amp, and gain is related to that. Okay, now we can make it as a one table of this one, and we can find out what are the name we can give it, and how to give the different gain names, gain equation, everything on this. In the first one, the voltage amplifier, we can give it name as a something called series shunt feedback amplifier. Next one, transconductance is nothing but it is transconductance, so it is series and series, we can call as a series amplifier. And trans resistance is nothing but shunt and shunt, so last one current is nothing but shunt and series. So these are the name usually we can call series shunt amplifier, series amplifier, or feedback amplifier. Okay, everywhere use feedback. And similar way, shunt feedback amplifier, shunt series feedback amplifier. So in this, what are the gain we can talk about? The voltage means it is the gain of voltage, so we can call AV is equal to, so in this voltage gain, output is voltage, input also voltage, so it is nothing but V0 divided by Vi. Similar way, transconductance we usually call as a GM, already we discussed. So here transconductance is third one. Here the output is current, so it is I0, and input is V, so it is Vi. So I0 by Vi is known as transconductance. Similar way, the trans resistance, here second one, so output is voltage, input is current, so output voltage current we can call as a RM. Okay, something like that. So it is trans resistance RM is equal to, so V0 divided by I0, nothing but V by. Okay, similar way we have one more, shunt series. It's very simple, we can call as a AI. Okay, the gain of current, so it's nothing but I0 divided by II. Okay, from these we can say that these are the four different type of feedback we have, and these are the name we can give it, and these are the gain I will get. Now there is one more very interesting names. Up to here what terminology we used? The first term refer to the feedback connection at the input. So feedback connection at the input is series, so we used as a series. Then second term is refer to the output, so shunt, like that we refer. Now one more, the type of name is possible. In this, how they are naming is a little bit difficult, something like that. First, there is a two type of naming possible. One is according to the connection, one is according to the input. If you go with the input, we have two types. One is current, another one is voltage. Okay. If you go with the connection type, there is a two type. One is series, another one is parallel, or we can call it as a shunt. Okay. So what they will do here, the thing is, they will take the naming purpose. First they will take as a output portion. Okay. But output they will take as a something like as a input type. Okay. Output they will take as a the type of the given. So output they will take type first name, second name they will take as a input connective. So what happens here, output type means, if you take first example, there is a two name. One name we can call voltage, another one we can call series shunt. So here what they will take, output type. Output type means the voltage is the type of the feedback given. So first they will take output type, so it is voltage. Then they will take input connection. So input connection, it's something like series. So it is called as a voltage series feedback amplifier. This is the very important. Almost everywhere they will give name something like that. So you have to know that how they are giving name. According to that we can make. So the first one we can make that it is voltage series. Okay, voltage series feedback amplifier. Okay, so this is the first. Second name, same way we can go that. Here transconductance means third one. Here the type of the part we can call as a current. So first output type, yes or no? So it is nothing but current, and then we have the input connectivity. Okay, in connectivity is nothing but it is series. So it is called current series. Okay, so here we can calling as a another name is current series. As usual, feedback amplifier. Similar way you can check with these two. So trans resistance means we can call as a output is voltage, input is shunt, so it is voltage shunt, and last one it is nothing but current shunt. Okay, this is the way of the another name of given of your amplifier. So we can call as a name but in another type. Okay, name. Usually this name is everywhere they use. Very less they are using like voltage feedback amplifier or series shunt, like that. Very less they are mainly using like that voltage series, like that name.